Welcome, and thanks for joining us. My guests today are Adrienne Simonson, the director of the NOAA Open Data Dissemination Program at the National Oceanic and Atmospheric Administration, and Patrick Keown, the NOD Program Manager at NOAA. Thanks to both of you for coming out to speak with us and learn more about everything going on data-wise at NOAA. I've heard it said from a lot of people working at NOAA that the mission covers everything from the surface of the sun to the bottom of the ocean. Pretty big range of things here. So just catch me up a little bit on some of the examples of that public-facing data that NOAA deals with and the customers who ultimately rely on that data.
Well, thank you for the question, Joy. It's really very good to be here. We much appreciate the invitation. And so there are, we have a lot. We have hundreds of data sets across all those areas that you mentioned, from the bottom, the surface of the sea to the sun, and they are so across the NOAA environmental focus areas. There are more than 56 petabytes of data currently across the 3 cloud service providers, and we typically provide the data sets that are most widely used. Those include things like near real-time data sets, which are like geostationary and low Earth orbit satellites, as well as weather forecasts and weather models and forecasts. We provide a lot of data beyond that in terms of oceanic data, as well as fisheries data and climate data. And we provide period of record for some selected data sets, as we'll talk about later on, some of those.
All right. And just given the scale of things, 56 petabytes, that's an enormous amount of data to be dealing with. What are some of the challenges of generating and storing all of that data and making it available, in some cases, to your point, Adrienne, in real time?
Yeah, thank you. And it certainly is a challenge to store just the sheer volume of the data, as you mentioned, from the surface of the sun to the bottom of the sea. We say it all the time. And one of our biggest issues is the fact that that's rapidly changing, and we don't know the volumes of the data that are coming. And that has been one of our bigger challenges. Here in a couple weeks, we're going to launch a new satellite that will be part of the the GOES program. That'll be GOES 19. And we have some testing, at least on the satellite front, to understand what those volumes would be like as that satellite goes operational. But for things like our weather models, that we did not anticipate that we would bring on a machine learning based weather model, for instance, or take all of these other weather models and maybe converge those into one that is more accurate, more reflecting of the science that we're bringing forth. And that's our biggest challenge, is trying to keep up in our program, trying to keep up in the organization, plan and adjust for the large amounts of data that are coming. The other issue that we have is that all of these data are different, right? They're different in formats, different in their unique kind of structure, also where they're housed throughout the organization. Each of those portions, from the sun to the bottom of the ocean, they have a different place inside the organization where they're developed, where they live. And it's our responsibility to work with them to get that data out to the public. And that is one of the challenges we face as well. But what we've done is work with our cloud service provider partners like Amazon, Google, and Microsoft, make that cloud storage available for us, and then make that available to the public, give them an opportunity to have completely open data access that's unfettered, that doesn't have any restriction to it, and give us the ability to really take that storage, take the challenge of that storage, and get rid of that piece of it so we can move and continue to do the things that NOAA does best, like open science and open data.
Yeah. Patrick, you mentioned satellites. Can you maybe explain some of the other areas or the other aspects at which NOAA is capturing this data and transmitting this data, going back to the bottom of the ocean and, other parts of the ocean as well? I imagine there's, ships kind of on the edge of things here. What else? Paint us a picture of what else is, transmitting and capturing that data.
Yeah, I'm glad you brought that up, because one of the data volumes issues that we weren't aware of a year, 2, 3 years ago was that of ships that would be collecting data. The landscape of bathymetry, which is the collection of data to understand the bottom of the seafloor and that depth, for a long time had been pretty static in the size that it was generating. As new technologies came on board, also as the availability of communications has increased, we're able to stream some of that data directly off of those platforms now. The issue is, where do we store that in the meantime, right, while it's sitting there waiting to be analyzed? And then unmanned systems. So I'm glad you brought up, things that are moving around, whether it's in the Earth's orbit or whether it's on the ocean. Now we have unmanned systems, uncrewed systems that are, along the surface of the water, that are below the surface of the water in the oceans and the rivers and areas that are collecting data. And some of those are collecting data for periods of time that we don't know, right? Like, we put them out, and some of the companies that we have worked with, they let them collect data until the batteries expire, and they have to bring them back in. So it's very hard to plan for those types of things. So again, working with our cloud service providers and working with cloud storage has really given us the ability to kind of accept all of that data, at least initially, decide what we need to continue to store, and then kind of move past that, decide what we're going to get rid of, what we can archive, and so on.
Yeah. It sounds like, with the example of unmanned systems, that surface is changing a lot, and that gives you, that forces you guys to kind of evolve with the times. Can you maybe unpack that a little bit more about how NOAA is, rising to the occasion as things like unmanned systems and just the surface area of what's collecting data changes?
Yeah, I think we've evolved by first just going back to, and our chief data officer, Tony Lavoie, and others in the organization, just going down, sitting down and planning for these types of things, and ensuring that, as we look forward, that when we start to talk about data in 5 years or data in 10 years, we're reaching out to every portion of the organization, every program. We work with the data owners to better understand what new data sets they're going to bring online. And then we have to work to create strategies, whether they're cloud strategies or data strategies, strategies for AI and things that would give us the ability to make those decisions long-term for the organization. And I think we have to be a little more flexible than probably the government has been in the past, right? We used to develop 10 and 20-year plans, and now we see ourselves developing 2 to 5 year plans that then often change in a year or two. So being flexible, making sure that we understand the data landscape as it is.
Just to zoom out here a little bit, can you maybe, for our audience, give them a better understanding of who NOAA's customers are for this data, recognizing that it can be a pretty wide audience of people if we're talking again from the bottom of the ocean to the surface of the sun, a lot of data from a lot of different buckets, from a lot of different topic areas. But Adrienne, can you tell me a little bit more about NOAA's customers and the people who rely on that data?
Absolutely. But first, let me point out that we don't know who they are unless they reach out to tell us, because we don't require people to register or be authenticated to reach the data. So literally, they have to reach out to us at our email, nod@noaa.gov. Our users span the sectors of the economy. We have users such as researchers and scientists that are using the data to analyze things like climate change and other significant events. We have policymakers and governments utilizing the data for disaster recoveries or other kinds of decision making. We have a wide range of sectors, so many that I will not list them all here, but I'll focus on the most important, which are agriculture, insurance, renewable energy, retail, and transportation. And I did say most important. What I mean is they're the ones that we're seeing the most on there. There are plenty others. But those folks are using the data for things like strategic and operational planning. They're also using it for risk management and supply chain management, and to create innovative products for their own users, their own customers. So the scalability and the access really allows NOD to essentially support the economy and spur innovation.
Yeah, and we've been talking a little bit about NOD, the NOAA's Open Data Dissemination Program. Can you just give me a little bit of an understanding of the origins of that program, how it's kind of rising to the occasion to meet the needs of NOAA customers as we've been talking about?
NOD actually started out as a research to operations program called Big Data Project. And we started it with cooperative research and development agreements with 5 organizations, including Amazon, Microsoft, Google, IBM, and a nonprofit called Open Commons Consortium. The CRADAs lasted for 3 years, and then we extended them a year. There was a formal process to find those 5. Then we went through another formal process in 2019 for requests for proposals. And by the end of that calendar year, so essentially Q1 2020, we had initial operating capability for something we were now calling the Big Data Program instead of the project. Then in 2022, Congress stepped in and provided support for NOAA and verbal support, encouragement, and we became NOAA Open Data Dissemination. And the contracts that set those up are essentially public-private partnerships that support NOAA's data democratization.
And when you say data democratization, what does that mean? I mean,
we mean more people can reach the data. So one of the reasons why this got started initially was because NOAA had a lot of data already that people were struggling to get to. And we were seeing the exponential rise of the data volumes, as Patrick was pointing out. Even though we didn't anticipate all of it, we still knew we were going to be inundated. So we needed something that would work. And so it started out, as I said, as a research to operations. And as we've gone forward, we've adapted, as Patrick was also saying.
You know, looking forward in that timeline, what are some next steps do you see for the NOD program, and where does it go from here?
I appreciate that. First, let me say that we did change the name because the Big Data project and program made it sound like it was only big data. And NOAA has data that's not big. A lot of fisheries data is not big at all, for example. As to what's coming next, we're currently in our 5th year of essentially 10 years of contracts. There was a 2-year base year with 4 option periods of 2 years each, and we're right about the middle of those. So we're looking to take on more data sets. We're also looking to continue to engage with our users to make sure they understand how to use the data. And while we speak, though, there are teams within NOAA that are working with each other and with the cloud service providers to develop the future data dissemination for NOAA. And I say that because, first of all, analysis of environmental data in the cloud is still quite new. And there are a lot of challenges, some we may talk about today and some we have already discussed, and others that we simply haven't even anticipated yet. They're coming. So as exciting as NOD is, it can be made better for everyone. Users, obviously, the folks that actually use the data, but even for NOAA and its stakeholders like the cloud service partners. We are looking to improve NOD all the time. And to that point, we would really like users to reach out to us at nod@noaa.gov and let us know what you think. Whether you have problems or challenges, we want to hear them because we want to make the program better.
Yeah. To that point, Adrienne, you were saying that NOD came into existence to meet kind of the needs of customers already, and that we've already kind of seen some iterations of this play out. Obviously, it's going to look different case by case, but in broad terms here, can you tell me some of the feedback that you've heard, that NOAA's heard about those pain points trying to access the data, and how you guys have internalized that feedback and made things better?
Yeah, I'm going to throw that question to Patrick, if you don't mind.
Yeah, I mean, especially early on and even now, we've gotten overwhelmingly positive support for data dissemination that we're doing, the data that is out in the cloud, and the access that we're providing, and that comes because we deeply engage with those users. It also comes because the overwhelming support of that is because the data landscape changed. As Adrienne mentioned earlier, it went from accessing data that was very hard, right? Trying to get to data sets through multiple entry points, maybe having to go through different APIs or user interfaces to pull data that was very hard to do before, opening that access up. And for some users, it was a pain point, right? Some users really enjoyed that kind of user interface, them feeling like they could find what they needed. But others, as especially large private industry, large research industry, they needed completely open access. And they were the ones that were providing early on overwhelmingly positive feedback to us. Some of those pain points, though, were for some of the other users, as I mentioned, a little bit of the access, a little bit of the findability. And what we're trying to do to address those is ensuring that our data set page on our website has a full and accurate description of the data holdings that we have in our program. It also gives them the ability to get back to the owner of the data. For instance, if it's a data set that belongs to the National Marine Fishery Service, it can directly link them back there. It could also directly link them to the cloud offering where they could access that data. So we're working on that. We're also working on ensuring that each of our cloud partners have landing pages for each data set so that users can understand the data set there. They can find the access points and really kind of interact with the data. And then we're also taking that interaction and the customer feedback directly to the data owners. One way we're doing that is through our engagement efforts. We have 2 great engagement personnel on staff that do a multitude of engagement events, but one of which that has come up lately is called office hours, and they developed this with the idea, especially kind of in the COVID times, right? Let's all kind of get back to almost having a luncheon or having lunch and learn or having a place where folks can just pop in. So we did that. It's a virtual event. We usually pick one data set and one cloud service provider, and then we really drill down on that. It started as an hour-long session. We quickly realized that needed to expand out. I think, are we at about an hour and 15 now?
Yeah, right.
So an hour and 15 minutes, usually around the lunch hour, at least on the East Coast of the U.S., that we invite folks in. They usually need to have some sort of understanding of the data set, because what we have done now is bring in subject matter experts of the data set from that office. For instance, one we did with a national weather model or national water model, where we brought in a subject matter expert of the water model, and then we brought our cloud service providers in to explain how to access the data on their platform, maybe show them how to interact with the data, visualize it, maybe run some of their tools that can be free for a certain amount of access and things, and how they could work with those and give them an entry point. And that's an open environment. We let them provide whatever feedback they want. We actually take all of the notes. We record the events, take all of the notes, and then we post that on our website, usually a couple weeks after we're done. So that's really how we're taking that information back. And what's been great is the data experts that come on board, they get to hear that feedback that they usually don't. A lot of these folks are scientists. They're in the weeds. They're doing their job, what they're supposed to do, and they love to hear that feedback. So we've opened that door for them and opened that door for our customers.
Really bringing everyone together. That's
Absolutely.
great to hear. Patrick, to zoom out a little bit, I've heard you both describe NOAA as this public-private partnership, and you guys have been talking about the cloud service providers who are providing kind of the infrastructure behind all of this. Can you just describe a little bit more about the cloud environment that is powering all of this, the role that the cloud service providers provide, and how ultimately you guys do that tag team effort?
Yeah, so over the past, I would say 5 even more years, NOAA's really been increasing its cloud presence. It's been increasing that cloud environment. That's been happening, as we mentioned. All of those different offices, all of the line offices within NOAA and the organization have kind of worked at that at a different pace, at the pace that they felt like they could do to both be innovative but also support operations. Folks like the National Weather Service, they have a very operational component. There's life and property that are at stake. So making major infrastructure changes take a little bit longer. Others like the National Ocean Science, who really are a lot on the forefront often of open science and trying to find new innovative ways to do things, they were able to maybe adopt cloud a little bit differently. What we did as NOD, and really as the big data project and the big data program, and as it evolved, it was our goal to help those offices get to the cloud and give them this infrastructure to at least say, here, we're going to utilize this for dissemination of data until we can figure out how to maybe do this internally, or we could figure out how to set up our infrastructure so that it could support a very similar mechanism. And we are there, I think, at that crux now of we're providing this service, and now they're all coming up to speed of how to build this cloud infrastructure, this cloud environment to support their needs and ultimately support the needs of the users, many of them new and different types of users than they originally had. So we've worked with them. Again, our program was very scalable, it was very flexible. the environment and the landscape has really changed, and needing to support massive amounts of interactions with data became one of those huge things. And that's what we were able to offer to the line offices by getting the data out, getting it into public cloud where there was no use restrictions. We did a study about a year ago on AWS, and we were seeing 1.2 to 1.5 billion interactions with that data per day for over 28 days straight of GOES data. That just wouldn't be able to be supported on the old, I don't want to call it old, right, but the on-prem infrastructure, the non-cloud type infrastructure that we had before we started moving into this cloud environment.
Yeah, really shows you kind of the night and day scenario of what you guys have been able to do. Adrienne, I heard you previously say about how the customer base, how you guys are meeting a really wide range of folks when it comes to their data needs. But I really want to underscore the significance of the data that these people rely on and how it affects their bottom line, affects their livelihood, and really the livelihood of so many Americans in this country.
Yes, thank you for the question, Jory. There really are a lot of dependence on this data. We hear from the users when there's a challenge, so we know that they're dependent on it, particularly folks who are utilizing near real-time data. There's a timing component as well. But we have heard from a lot of individuals from startups, for example, that they could not have started their company without access to the data being free. We also hear from Fortune 500 companies about how useful it is to have the data on the cloud.
I would say, to build on that, some of these folks that we've heard from and that we've also had the unique ability to interact with in forums like conferences or things like this, we've heard from these companies, these startups, like Adrienne mentioned, that really, if to your point, they affect folks' livelihoods. Some of these startups actually are coming in and doing wildfire detection, for instance, something that has been a major issue in the past decade and hasn't really found a good solution. And these folks were able to take laptops and then utilize serverless cloud computing technology and access to the data that we provided, and then generate their business, which great for them, but also generate something that affects everyone's livelihood and can benefit everyone as a whole. And what we didn't mention when we were talking about the cloud partners is they're also benefiting, because so many of these things like Amazon, and others, Google, they provide services to us, right? They have storefronts, they have all of these things. They need data and information to drive the back end of that, right? So route planning, for instance, logistics and all of that. So we've had the opportunity to sit on panels and have conversations with folks that are saying, for your product that's in your refrigerator to get to your shelves, we're assisting that company, a Fortune 500 company, in ensuring that it's going to stay refrigerated. And the only way for us to do that, though, efficiently, and to reduce our greenhouse gas emissions and all of these other things, is to understand what the weather's going to be like. And we can only do that if data is unfettered, it's open to us, and then we can utilize our infrastructure and capabilities, high performance computing, to make analysis and make decisions. And it's been great working with those types of customers to do that.
That's true. I will also add that universities, educators, and students are also using the data, and they're in their curricula, which is great. We need a whole army of folks who can analyze the data in the cloud. There aren't enough of them. So having NOAA data in the cloud for universities and educators to use with their students is really a very practical way to learn how to do this.
Well, Adrienne, thank you for explaining that. Patrick, just to understand a little bit more of kind of what the possibilities are out there, because it does seem to me that beyond this established customer base that already knows and relies on this NOAA data, there's other opportunities out there. There's other people who may not immediately know about these data resources that NOAA has, but could certainly benefit from them.
Yeah, and it's funny, we started this by saying, again, we have data from the surface of the sun to the bottom of the ocean, and I think some of the opportunity we have and the untapped resource of NOAA data is that a lot of folks don't understand that, right? They may understand portions that affect their lives, like the Weather Service, right, and having these forecasts and warnings, but they may not understand that there's all this other data that is out there and that we're making available, not just through our program, but NOAA as a whole, through our archives at the National Center for Environmental Information. And I think that us getting the data in the hands of new users, as we mentioned before, folks that maybe are coming and saying, well, I may not know as much about the data, but as Adrienne mentioned, I'm an IT professional that has now gone through and gotten an understanding of how to do artificial intelligence and machine learning. And NOAA's data, foundational data sources that we provide and that other government agencies provide are really, they're the foundation of artificial intelligence. They're the foundation of machine learning. I think that is the untapped resource that we're starting to see. We're also seeing those customers come to us and say, hey, I know I used to want weather models, but now I want satellite observations, and I don't want them cleaned and analyzed in the way that we wanted before. I want the raw data because I understand how to get that and create that into something that can train an AI model or train some sort of large language model, as we're seeing with things that are coming up all over the place. So I think that's one, and as Adrienne mentioned, just our educators too, getting data in the hands of educators, because they're educating the future of the individuals that can, drive both ends of the spectrum, right? They're educating future weather forecasters. They're also educating those that are in computer science. They're going to be able to do this large-scale analytics. We work with West Virginia University just recently. Adrienne has a little more information on that, just how we work with them.
They've started a program called Cloud Analytics Data Fellows. And so they are incorporating NOAA data into their curriculum in order to essentially turn folks into data miners, right? It's a great program that gives the students an opportunity to understand, first of all, the untapped resources that are there, and to start thinking about the problem from their own perspectives, and hopefully they will learn how to bring it to bear to other larger societal challenges.
Yeah. Well, thank you for outlining all of that. I think this really gets back to, and if you'll permit me, a bit of a weedy question here, but it really seems to get back to the Foundations for Evidence-Based Policymaking Act. You talked about NOAA's CDO before. This is legislation that made CDOs a commonplace thing at all agencies, and really gets back to this thing you guys have spoken to time and again, is just kind of making the data a strategic asset. It doesn't benefit anyone if the data is out there, but they don't know about it, and that they don't have it available in a format that's easily accessible. And you guys are doing just that. Just recognizing that legislation and how far we've come in a relatively short period of time, how do you see this work and just kind of the NOAA mission right now really delivering on those kind of key tenets?
Well, NOAA really does, NOD really does support NOAA in making sure that we're living up to the Evidence Act. NOD makes NOAA data assets available to the public at no charge. We publish those data assets as machine readable. We maintain a data inventory. We engage with the public on the use of the data in order to expand the use of the data. And we provide the public with an opportunity to ask for the data sets they might want. Patrick has already referenced some of this, but our methods for engagement are significant. Well, there are our email, which is nod@noaa.gov. As we said before, users can write in and talk to us about their challenges, and we're going to answer their questions. That's super helpful. The other thing is the office hours that Patrick mentioned, which really allow folks to join from the comfort of their desk and learn about these topics. And I'll also say that those materials are available on the website afterwards, as Patrick mentioned, so that you can go, even if you weren't able to sit through the initial one, the materials are available on the website now. We actually have our last couple of office hours were April 18th with the Joint Polar Satellite System, which is a low Earth orbit data set, and that was with Google, and we're about to do the Joint Polar Satellite System with AWS on June 13. So those materials should be available about the time folks are seeing this webinar.
I think one great thing that you mentioned too is that, and to the Evidence-Based Policy Act and that, is that was portions of that were supposed to, as Adrienne mentioned in her fourth point, was to push the organizations, government agencies to engage with their users, engage with the stakeholders. And what our engagement lead would call it is now we're trying to focus, because of that, on active engagement, not passive engagement, which I think was usually what was utilized and thought greatly of as engagement in the organization, right? Hey, we have a website and we have a form that you can type your name in and say, hey, I want to learn more about something. That wasn't enough. And I think that was some of the legislation and things, was to push the agencies to do more, to get more information to their stakeholders and data users. And that's why all of these things that Adrienne mentioned are really what we're calling active engagement, going out and being much more proactive and actually trying to push users to come to us versus just sitting there and letting them kind of come in.
That's great to hear. Patrick, you talked about machine learning, artificial intelligence, some things that are not just over the horizon, but in many cases already here. Tell me a little bit about that. Obviously, both in the government space, there's been an appetite to do more of that, and also with the private sector, a lot of the stuff is off and running. And you mentioned to some degree how that's kind of changed the expectation from customers, what their demands are. But tell me a little bit more about where NOAA sees the space of machine learning and AI kind of driving this new chapter of NOAA data.
I'll start by saying I'm certainly not an expert in AI or machine learning, so anything I say is definitely off limits for anyone to go back on. But I think what we're doing as an organization and what NOAA is enabling and helping with is really fully embracing artificial intelligence and machine learning. And that took a little time and we got there, but we've stood up the NOAA Center for Artificial Intelligence, for instance, which is kind of all agency spanning, brings together experts not only on the data front, but on the analytical front, on the computer science type front, to better understand what we can do to make data more accessible for artificial intelligence and machine learning. That may mean emerging kind of data technologies as far as different formats that ensure that data is cloud optimized. So we work with that center, the National Center, or the NOAA Center for Artificial Intelligence, to ensure we're optimizing data sets. Another way we're fully embracing it is just recently we released, in conjunction with the National Weather Service, I should say, released in conjunction with us making the data available, an experimental global forecast system, or GFS model, which folks are usually pretty familiar with. An experimental model based on GraphCast machine learning weights and models. So it's us looking at the community and especially that private industry and saying, hey, we need to stay on the forefront of things like weather forecasting and modeling. We can't let this technology surpass us. We need to stay up to speed. So the Weather Service and others are doing that, and they're ensuring that any of that emerging technology that they're staying up to speed with. I also think what we're trying to do is ensure that data is accessible in the right way, not only making it easier for users to find, but making it easier for NOAA to manage this vast amount of data. So we're looking at things like spatio-temporal asset catalogs, or STAT catalogs, which just make geospatial data a little bit more common, a common language, easier to read, easier to find, easier to use, and again, easier for us to manage. And then again, back to cloud optimized formats, looking at things like chunk libraries that basically leave the data in the format it's already in, but give it this kind of library or sidecar to then enable cloud computing to look at it in a more efficient way. I mean, that's how we're really supporting that.
Yeah. Just to underscore that, Patrick, it sounds like if not for this cloud infrastructure and the ability to have data at your fingertips in real time or near real time, that this automation revolution really wouldn't be able to get off the ground.
Yeah, I agree. I think, and that's some of the things that we've heard back from the users, is that it's really the access to the real-time information that has been critical early on. As we mentioned when we first started, that was always the thing. Hey, great, thanks for the real-time information. Thanks for the real-time information. But again, as we're seeing the landscape change in AI and ML, it's, well, that was great, but now I need everything you have. You know, NOAA may have 50 years of one data set in an archive, and to understand how we can move forward and develop these types of models and things, the users are needing all of it. And that's what we're providing that access as well. Not just NOAA, but NOAA as a whole, ensuring that we've kept good archives, we've kept good records of these things. We never knew probably 20 years ago that that was going to happen, right? That folks were going to need to have data not only coming in real time, but then also feeding kind of from the other end of it.
Yeah.
Yeah. This is why period of record data sets are so important for AI and other purposes. And we're working to do that. For example, Joint Polar Satellite System data is, we have the entire period of record, and we're working to do that with other data sets as well. And it makes it easier in some cases to do other things with the data. So there's an example of NexRad, for example, where the folks utilize 30 years of NexRad data to study bird migration, and discovered that we've lost 3 billion birds over the course of, I think it was 30 years.
I think that's right.
And so they're using the data for purposes that it wasn't intended, just exactly what Patrick was saying. There's other examples of this, although not necessarily to do with period of record. Folks have recently discovered ways to use GOES-R to look at methane hydrate leaks. You can pick them up on the Joint Polar Satellite System, but it doesn't stay over long enough for you to actually see what the leak is doing, but the GOES-R does, because it's permanent. I also wanted to say that NOAA is a contributor to the National AI Research Resource Pilot. I think I got that right.
You're right. You're right on. Yeah, rolls right off.
Yeah, no, we've heard a lot about that. That a lot of agencies are kind of pooling their resources, making them available. These kind of sandbox environments for folks that are not in the federal government to kind of work with that and
Right.
foster and incubate their own AI projects or machine learning or things of that nature.
Right. And the AI data sets that are available on NOD, and they're working on more. So those data sets will be there soon.
Excellent. Well, we've talked a lot about AI, we've talked about machine learning. Are there other emerging technologies, other things over the horizon that you guys are keeping your eye on, or things that you think will kind of evolve the NOD program and force NOAA to stay on top of?
I mean, I think really we're trying to, unfortunately, a little bit too, and the government as a whole catch up, and the emergent technology is things that are being brought to us from private industry and private sector. And what we're trying to do in this program, NOAA as a whole, is to listen to that more and more, even maybe more than we used to, really kind of pulling two of your comments in together, the emergent technology and then the Evidence-Based Policy Act. We're trying to find those communities now, like Earth Science Information Partners, or ESIP, these kind of community-based infrastructures that we can interact in the community, find out what's coming new, and be a little more on the forefront than we used to as I think an agency. And that's what we're trying to keep our eyes on. Plus, going back, we're still also trying to just keep up with the current technology, right? I mean, as we talked about earlier, the entire organization isn't in the cloud yet. We're going as hard as we can. We're rapidly evolving, but we have to also ensure that we keep up with the current landscape as we investigate some of these emergent technologies. But I think for us, it's ensuring that we're looking forward, that we're taking the advice of private sector and also our partners overseas. We've met with European space agencies and things, and European weather agencies, to say, hey, what are you all doing? And especially, what are you doing as far as data dissemination? How are you doing it? What technologies are you using? What licensing? All of that, kind of the whole landscape, and just ensuring that we're kind of ready with all the information we have to be able to move forward.
I'd also like to add that one of the things NOAA as a government agency needs to do is thread the needle between providing what only the government can provide and allowing those folks with great business ideas to do that, right? So we don't want to take on the role that industry can do. We want to provide what government needs to provide and let industry take it from there.
Yeah.
So
Speaks to the parent department of NOAA being the Commerce Department.
exactly
Absolutely.
right. Exactly right. And to your point, I think it will continually evolve. You know, we're in a very unique spot. I don't think we can predict all the things that, all the challenges and all the benefits that are going to come from this activity, from analyzing data in the cloud.
Yeah. Patrick, I wanted to circle back to the comment you made about NOAA as an organization not fully in the cloud yet. Do you have a sense of like that timeline, whether there'll be more elements that are moving to the cloud? Are there elements that will just, by the nature of it, stay on-prem? What does that look like?
I probably can't speak all the way to that without having a full understanding of the full landscape. But we are seeing even parts of the organization that we weren't even aware in the cloud, just through different avenues and different meetings that we have that they've already come on board. Some things that we weren't aware of coming on board. I think some of our things, like all of our high performance computing infrastructure, that's still in these research stages. Can we do all this? Can it be feasible economically? I think some things too are in the world of IT that things have lifespans, right? And things need to run the span of their life before then it makes a lot of sense to go into something new. So I think the organization, as I mentioned before, is each piece of it is figuring out what is best for them, what makes most sense from a budgetary standpoint, from getting funded to do it, right? And there's, as I mentioned, things like the National Weather Service that have to continue running operational capabilities while they also build out all of these new technologies. That's a resource strain, that's a budgetary strain at the end of the day. So I think we're getting there. I think, again, there's portions of the organization that we probably aren't even aware of that are either moving into the cloud or may not be in the cloud yet. But I think the organization as a whole is moving in the right direction.
Yeah.
Great.
Well, one element of this that's really impressed on me is the idea of community. You guys have been speaking about outreach to international partners. Of course, here stateside, there's a vibrant and excitable community about data. We have a CDO council where interagency, they share these exciting ideas, and we've spoken a little bit about some of those linkages with the data. Just real quickly, can you explain to me that community of agencies and how you guys are putting your heads together to come up with exciting new ideas of what the data can do?
So we work with various agencies, some of which you would know that we probably can't talk about too much. Mm-hmm. But I think the key is that we continue to do that, that we continue to open the door to sharing data to, and that's been a conversation with our cloud service providers and things as we put data in the cloud, for instance, it's still going into separate locations, right? It's just like NASA data is at NASA and NOAA data is at NOAA. When NOAA data is in Google in this place and NASA data is in Google in this place, and we're trying to work with them to bridge that gap, agency by agency, and how can we collaborate better? Because we do so much collaboration with other agencies. We're working on, or one of our NOAA offices is working on partnerships with the Corps of Engineers, for instance, on projects that they have joint interest in. And the biggest issue is sharing data. It's getting away from having to go, even if they're in the same building. I mean, we have government agencies and regional offices throughout that may be in the same building, and yet they were carrying hard drives, right? How can we share data in the cloud? But especially with those agencies like the Corps of Engineers that are under Department of Defense, how can we do it securely? Because us, NOAA, as a open science organization, we're so keen and ready to just put the data out to the open. There's not really use restrictions. They may not be able to access that data in the same way because of their own internal issues and firewalls or whatever that may be. So we are actively exploring that. I think, as you mentioned, and we can't speak to it as much, but the CDO councils and those things coming together to say how is each organization moving forward, and how can we do it together? Yeah.
I'd also like to point out that we actually have a global user base. We have folks all over the world using the data. There are companies utilizing NOAA data. One of the reasons for that is because we have data beyond CONUS, quite frankly, right? For example, we have geostationary satellite data from both Korea and Japan. That came to mind because Patrick was talking about moving data on hard drives. Well, that's how we got the original Himawari data from Japan, is it came on hard drives. It took months to get to us, right?
Yeah, that happened during COVID, and there was shipping issues, not being able to ship out of the country and all of that. And it was interesting to have that issue and then try to work with Amazon and Google and Microsoft to say, like, are there other solutions here? What else can we do to make this happen? This is the environment we're in. We should be so much more advanced, but yet that was still the best way that we made it happen. And then got it on the cloud, and now everyone's able to access.
Wow.
So we really appreciate the Evidence Act's requirement to get the data out there because so many people are using it. But I'd like to point out that as team members, what we're really excited about is that these folks are using it to solve some of the challenges that we're all facing.
Yeah. Well, you guys have come a long way, and we've covered a ton of ground here, but I think we're going to have to leave it there. I'd like to thank today's guests, Adrienne Simonson, the director of the NOAA Open Data Dissemination Program for the National Oceanic and Atmospheric Administration, and Patrick Keown, the NOD Program Manager at NOAA. I'm reporter Jory Heckman, and you're watching Federal News Network. Now let me send you back to the studio for more on the Cloud Exchange.